I'm going to record this video to go over my most recent D100 build, just explain kind of what's happening in the build, why I did it, and what went wrong. So yeah, this is a D100 hbot mod with an open front. So let's just go through everything that's different from the original 100. So first of all, the most important thing in this build is the kinematics. So the regular 100 is a Core XY printer, and that's I guess popular, fast, kinematic. It works very well. Does what it says on the tin. There's really no reason to change it. hbot is basically a worse version of Core XY. It's like a primitive version. So Core XY would usually use, it uses two motors, each with their own belt loop, to work together for XY movements. hbot, it also uses two motors that work together for XY movement, except they're on the same belt loop. That's really the only difference. In fact, the motor inputs are exactly the same. If you convert your printer from Core XY to hbot, you don't even need to make any changes to your Clipper firmware, which is pretty cool. There are some significant downsides to an hbot printer, this being racking. Because of the way force is applied to the gantry and the tool head from the belts, it causes the x-axis to kind of tilt. And so if your system isn't rigid enough, maybe you have poor tolerance bearings or something like that, you'll have your x-axis just kind of wiggling around a little bit. Not necessarily enough to see, but enough to have a negative effect on your accelerations and print quality. Also, because of this, you have to have pretty high belt tension. So that's just kind of something you need to manage and deal with as well. And this increased belt tension will put a lot more stress on your motors. In fact, so much stress, in fact, this is not the first time I've built this printer. I made like a first version of this. And actually, after only a couple of test prints, the shaft of one of the stepper motors just snapped. It completely just snapped in half because, well, tension being applied sideways to a rotating steel column is generally not that great. So I had to redesign the motor mounts. I'm not sure how well it will come out on camera, but you'll see the bottom of the stepper motor shaft down here is actually sitting inside of a bearing, which is sitting inside of the frame. Usually there's just kind of nothing underneath the motor shaft, but yeah, it doesn't really come out on camera, but it's just kind of sitting inside a bearing. It is inside the frame. That way, when tension is applied, trying to pull the shaft this way, it doesn't tip the shaft. It tries to tip, and then it pushes into the bearing at the bottom. And well, so far I haven't broken any more stepper motors, so that's good, I guess. Yeah. The reason why I made it in hbot, even though it is objectively worse, is it just kind of looks cool. I think it isn't as kind of intuitive with kind of how it works when you just look at it. I suppose I might be speaking for myself, but when I first saw an hbot printer, I just kind of thought it was pretty neat and kind of weird how two directions of movement can be controlled by a singular belt loop. I thought that was pretty cool. And also, because it's a single belt loop and the way it's attached to the tool head, it kind of looks, and it looks kind of weird how the tool head moves from side to side. because the belt is fixed. One of the belt rows is fixed into the tool head. The other passes through a hole in the tool head. But you don't necessarily pick that up when looking at it, so it just kind of looks a little funky. Yeah, and that's frankly the only reason why I decided to make this hbot. Zero practical reasons. It is objectively worse. I can't print as fast as the standard, as I would on the standard machine, but I think it's just kind of neat. You don't really see many hbots for those reasons. Yeah, so this of course did require me to adjust the way motors are mounted, adjust the belt tensioning, and also fully design a new gantry and tool head. This is actually one of the benefits of hbot. Since it's a singular belt loop, it's really easy to design and assemble hbot components. Can't really see it there necessarily, but it is very, it's a really basic design. The tool head as well, it's very simple. No frills or anything. It is using 10mm belts, since there is a lot of tension, so you just want the belts to be nice and stable and rigid. And then, instead of using regular belt idlers inside of the gantry, I'm using a stack of actual solid bearings. It's the same flanged bearings as are on the standard 100 gantry, but with a non-flanged version of the same bearing in between them. This is because the high belt tension, if you try and have that kind of belt tension with just regular standard idlers that have those little puny tiny bearings in it, they're just gonna wear down very quickly. You're gonna have a bunch of issues with that. When I first started wanting to build this printer, I was kind of doing a bit of research, and I watched Rolohan's video on his original Simple Cube, which was going to be an hbot, but he had decided against that because of how much the idlers were wearing down, because he was using the regular idlers. So kind of just to get ahead of that issue, that's why I use those much more beefy regular bearing stacks. Yeah, then that's pretty much the kinematics. The next thing is, well, big open frame. The regular 100 has a beam across here, and that works fine, but it does kind of block the view of the print going on. It does kind of block the tool head, makes it a little weird to grab at the prints. Yeah, and this, again, much like the choice of the kinematics, it is objectively worse for stiffness. I'm not going to do it right now since the printer is printing, but if you were to grab the sides, you can push them together pretty well. There's a solid 2mm. You can just kind of push them. Well, if the x-axis is back, if the x-axis is all the way, y-axis is all the way forward, there's less movement, but when it's all the way back, you can really flex the frame quite a good bit. But, it looks cool, so that's fine. The purpose of this printer is not to be some high-performance machine, it's to basically print out quick prototypes when my main printer, for now, is busy with something else. Because I just keep on finding myself needing to print something quickly, but this guy is being used for something a little bigger. Yeah, so instead of just the regular X-rods in the front, because actually in the standard 100, there's no printed parts vertically in the front, it's just the Z-rods. So we have one beam in the right in the front here. It wraps around to the side and is also bolted in the sides, and then diagonal beam here, mounted with this really aggressive plate at the bottom. These are all M5 connections. In fact, that's another thing with the printer. Everything is M5, and it's not heated inserts either. These go through the frame. There are nuts embedded in the back. Heated inserts really are not that good, just by the nature of how plastics respond to different types of load. Heated inserts really are not what you want to be using if you really want something to be stiff and strong. They work just fine, and the regular 100 build uses heated inserts, and it works fine. But they are not the best possible option. So yeah, I switched everything to just M5 through bolts. There are still some M3 heated inserts in some spots here and here, but even these are kind of assisted with M5s on the side. Yeah, but even though M5 through bolts are better than the standard heated insert solution, this still isn't actually that good, because generally when it comes to kind of printed parts and these kind of designs, you really don't want to be using screws and bolts to establish strong connections. You want them to kind of reinforce existing connections, if that makes sense. So instead of trying to join two things with screws, what would be better is to join them with, say, a dovetail type thing, and then reinforce that existing connection with screws. I think this is something that Matt has said he will introduce with the V2 of the 100. I'm not 100% sure on that. But yeah, so I think that actually the flexing that I mentioned from this open frame I could have probably avoided that had I not just had it be bolted together, if I maybe added some dovetails, if I somehow enhanced that connection in a way. But it's fine, it works. There are some print quality issues with this printer, but at the moment I can't really blame any of them on flex caused by this open frame, so that's good. I imagine that if I were to try and print stupid fast speeds like I have done with some of my previous builds, then this would be a problem. But if I'm just printing sub 300 millimeters a second, sub 15k acceleration, I haven't seen any issues that can be attributed to this so far. So I'm pleasantly surprised by that. I did expect this to be the main problem with this design, but turns out it wasn't. I had far more issues with motor mounts. Yeah. Yeah, I'm quite happy with how it looks. Yeah. Next thing I'd say is, well, I guess CPAP. Though this was also my previous build, so it's not especially new. It's connected to just a 120mm radial fan in the back, which goes into this printed duct. It is mounted sideways, which is it's suboptimal if I'm using just one fan, but originally I did want to have a second one of these towers below that, and the only way to make that fit is having this sideways. So that's why this is sideways, but I don't have that second fan there because when, I'm not actually sure when it happened, but at some point I must have bumped something, jostled something wrong, and only one of the sockets for the fans on the SKR Pico works now. So I'm forced to only use one fan. I probably will at some point just resolder that socket, but honestly probably not actually, because this one fan is more than enough. I don't really see why I really need to, unless I were to go back to two regular radial fans on the tool head. We'll see. Then I do also have built-in stepper motor cooling. So since this is a printed frame, this is printed out of just natural Orapole PLA. Well, PLA doesn't really like temperature very much, so if you want to, print fast, get these stepper motors warming up, you're going to have some kind of cooling. I think this is true for all 100 builds, honestly. Like, a heat sink at least really is mandatory. I don't think you should be raw dogging your stepper motors on a printed frame. So I just have kind of, I don't know what the technical word for it would be. Basically, there's a little chamber where I just have a regular 4010 fan on top, blowing in. It's blowing over the top of the motor, down the side, and then there's like an exhaust in the back. If you hold your hand down here, you'll feel the air coming out of this duct. Actually, yeah, you can kind of see it there. It's pretty effective. I kind of have stuck my finger up here a few times to feel how warm the motor is, and they're not warm at all. So that's nice. Yeah, I mean, those are really those are like the three big things about this build: is kinematics, open fronts, stepper motor cooling. Yeah. Like I think I mentioned earlier, this is not the actual first version of this printer that I've made. There's made a first prototype of this, where I printed the entire frame out of carbon fiber PETG, which was a horrible mistake. I regret that incredibly, because PETG is significantly less stiff than PLA. But I originally wanted to also enclose this printer, so I kind of wanted something that was temperature resistant, and I thought that the carbon fibers would help add stiffness to the PETG, because according to the datasheet for the CF PETG I used, it should have been actually significantly stiffer than regular PLA, but it was not. So that frame was just flexing all over the place, and that was actually before I implemented the M5 through bolts. It was all still heated inserts at that point, and heated inserts and PETG really don't mix very well. If you leave heated inserts in PETG under tension for more than 10 minutes, they will just start creeping their way out. And actually, when I disassembled that frame, I found that the majority of the heated inserts were already halfway out of the pieces that they were supposed to be in. So yeah, just word of warning, don't do that. That's a great way to waste 120 euros worth of filament, which is really, really cool. Much better to just use 50 euros worth of regular PLA and not enclose it. Yeah. I'm still using carbon fiber PETG for the tool head and gantry. These are printed with high enough infill and wall settings that I just assume they'd be fine. I kind of like them being black as well. Yeah. I mean, that's pretty much it with this printer. It is objectively not good. It is worse than a standard 100. It is worse than all of my previous versions of the 100, but it's kind of neat. I think it's just kind of cool. Open frame hbot. Yeah. I'm probably not even going to use it that much. I'm probably not even going to use it. It's just kind of like a fun little project. Fun, silly project. Yeah. I think that I will kind of stop with the 100 printer for now. Probably the last year I've just kind of been the 100, and mods for the 100 have kind of taken up most of my time. I'm gonna be moving on to other printing projects. Primarily, I want to build a large format Core XY, like a full custom build, kind of similar to like a Voron or a Rat Rig, but again, like full custom. I'm still in the CAD stages for that printer, and it will probably be pretty expensive, because I kind of want to make it pretty premium. So it's probably going to take a few months to be able to afford and then build it. But I think during the process of that printer build, I will try and upload some videos about it, because it will be a pretty complex build, and there's going to be a lot of weird Clipper stuff for that, which I will try and record, because in my research I've found it pretty annoying, like the documentation about certain things. Yeah, anyway. Yep, I hope you found this interesting. This is kind of me rambling about this this crappy printer. Yeah, hope you found it interesting. Yeah, just watch out for some videos in the future about much better printers. Yeah, thanks for watching.